In this tutorial, we'll do the planning for a Firebase backend. Hey guys, welcome back to episode 3 of the boxed out planning. If you don't know what boxed out is, head over to FilledStacks.com/boxed out. We are building an open source food delivery product and service that will be developed on the YouTube channel that you are watching now. Please make sure to subscribe so that you can see new videos when it comes out. In this episode, I'll be going over the discussion that we had for the product architecture planning. The title for this discussion was actually a bit wrong. It should have been System Technical Overview. The reason for that is because we are going to cover how the system will be working in a more technical manner compared to the first 2 episodes, which were both high-level looks at the architecture. So the way that we did this planning and discussion is that I detailed 9 steps that will have to be taken for us to get a user's order back to them as a physical product, or in this case, a meal from a restaurant. So there's 9 steps, but we'll go through all of these steps and see what the discussion led to, which is the final document called System Technical Overview in the wiki for the repo for the boxed out project. You'll see it on the right side under the System Technical Overview. This document is the summary of the discussion that we had. So instead of giving you the final discussion, this time I want to go over the actual discussion that we had so that you can see and maybe learn the process that we follow when we do the internal planning as well. So the first few things in the discussion was from Fernando, which is on our FilledStacks team. He mentioned that I was calling the functions for each of the management services, I was calling them groups. And he recommended that we use the API conventions for a RESTful API. And in that case, it's called resources. In addition to that, you use the multiple for the resource name. So for the order management, it would be orders, and for the user management, it would be users. So that is something that's also detailed at the beginning, where we talk about the API, the backend insights, as well as the wording for things that we'll be doing and how we'll be naming certain things. The second thing was a message on LinkedIn from Rodrigo, who mentioned that we should be using the Express server for the cloud functions. This is something that I have done in the past and I forgot to mention it in this document, so it's good that it was brought up because it needs to be a part of this technical overview. Basically what we decided is that each of the resources will expose only one cloud function. It will be the resource endpoint, meaning for the user management, we'll just have a cloud function that shows the user's cloud function. The rest of the route will be handled internally by Express inside of that cloud function. This doesn't mean that we'll only have one file. It just means that we'll only have one cloud function, and then internally we will use different functions or functionalities based on what the Express route determines. And yeah, those are the 2 technical overview things that needs to be mentioned before this document, because it's not actually a part of the creation of the technical specifications for the system. Let's go over the steps quickly. I don't want this video to be too long because the technical document isn't that long. It takes about 3 minutes to read, so the video shouldn't be long as well. I do want to give you more details than you would get if you had to just read the document. So I'll go through it step by step and just go over some of the things that was discussed and what we chose. Number 1 is the user adds a product to their cart. This will get us thinking about how we're gonna manage our carts. There's 2 ways of doing that. You can do it remote or local. I basically just wanted to have local as an option so that I have something to compare the solution that I'm favoring against. So the way that we'll do this, or what I decided, is that when we create a user, we will generate a cart ID and attach that to their profile. At the same time, we'll create a document in the carts collection which will belong to that user. When we add something to the cart, it goes into the cart specified in the user profile. When we check out, this cart will be cleared and the info will be dumped into the order information. The user will basically have one dedicated card throughout their lifetime on the app. We will reuse that card and we'll know exactly what the card ID is at all times given the user ID. This makes it so that adding to cart is quite simple in terms of a logical standpoint. We can add directly from the app into the Firestore DB for the cart. We can either add this as a sub collection or we can add it as an array of items to the document itself. To keep things simple, I think it would be best if we add it to the document as an array. The reason for that is if you have it as a sub collection, you're going to have to do another read request to get the data from that collection. The total card cost will keep in sync. We can use the atomic update functions to make sure that we are increasing the count in an atomic fashion and that it will always be in sync with what the card is actually reflecting. The second thing we have to tackle is adding a payment method. So before a user can check out, we need to have a payment method. This will be an API endpoint. PayPal V2 API and Stripe is not available in South Africa, so I will be discussing more about the third-party integration when we get to that point. Specifically, this will only be to explain how we are going to be interacting from when the user wants to check out and having to add that card. We'll basically expose an endpoint where we will pass up either the token that was used or the details of the user, which will give us back the charge token that we can use to make the payment from the user's account. That usually works by sending up the details for the card and then getting a token back that can be associated. We won't store any of the card details. All we'll do is keep that token on the user's account so that we can access it when we want to make the payments. And next thing, the main part is the checkout process. It's quite big and it covers basically all of the other steps in the rest of the steps that we had. We'll start out with the way we want to use this in the code. What I want to do when I check out is just call one endpoint checkout. When this is done, the order should be placed and everything else should be completed. What that means is we'll have to do some things on the back end, which is what we are deciding in this document. The first thing we do is we use the payment token attached from the technical specifications defined up here, and we request the payment from the payments resource. This will be done using a basic HTTP request, meaning the payment management system will have to expose a cloud function where we can make a request using a token, and it will return to us either a receipt or an error that describes exactly why this payment couldn't be processed. If the payment failed, we show the error returned and we bail on the process. The errors will be returned in a consistent format so that we can always check on every single response if there's an error available. If the payment passed, we create the order in the orders collection. That will contain the cart and all its information as well as the status. When the order is created, we have two options. We send the push notification from the function that's currently handling the checkout. This means we'll have to mix the code into the function, which I don't like. The second option, which is what we decided on, is that we want to create a cloud function that is attached to the orders collection. This will listen to a new order, and then when a new order comes in, it will send out a push notification to the two parties involved in that order. That will be the merchant as well as the user. This will allow for better scaling, and I think it's the best approach given that it will be reactive based on when the orders are placed, and will also make the main function return faster because it doesn't have to await the sending of the push notification call. Once all of this is complete, we want to return an order ID if the input was successful and the function has passed. Once we have that order ID, then on the client, we want to clear the navigation stack and navigate to the order status view, passing the ID return from the checkout request. In the order status view, we will listen for the real-time updates of the document matching orders/order ID. This means that as the status updates and the user is watching the screen, which happens in the real world, that status will be updated in the most real-time manner that we can possibly manage. Then on the restaurant app, we are subscribed to the orders that match the restaurant's ID in real time, so those will be updated as a new order gets placed. Using the steps above, we can populate a cart from the user's device onto the restaurant app. This is the biggest step to get over, And this allows us to then track on the device the order status as well as receive the updates for it. This just goes over the response we want to send back in a consistent manner so that we always have data to serialize or an error. If the error is not null, we will always show the error message that's displayed in this response. This means we can handle all of our error handling within the cloud function service that wraps all the management services calls into that function. Francisco Passin also had a lot of input, and it's a lot of things that I considered as well. We will still return the status codes, but I don't want to have the strings in every single client of what the error is that we want to show. The backend will return us a friendly message that we can show exactly as it is. And then next up we have the restaurant app. This is steps 5 to 9, where step 5 is the order shows up at the restaurant confirms, restaurant marks as ready, driver gets the order, driver delivers the order. Steps 5 to 9, the customer mobile app will be reachable through direct notifications using the latest device token as updated on every launch. In addition to that, the client will be listening to the order in real time that's being viewed. This leaves us only the restaurant app and services involved to detail for these 3 steps. So if we look at the order updates, we'll have a cloud function listening to the order. So it'll be listening to the trigger for orders/document ID. So any document that gets updated, we'll check the status of the data for that document, and based on that status we will send out the appropriate push notification to the 2 parties involved if both of them require it. We might have to maintain 2 collections of orders, one with full orders and one with a simple orders list that can be listened to in the listing view so that we don't read all the information. That's just something that I noted down because an order will have quite a lot of JSON information in that. If we don't need the detailed information, we can maintain 2 separate orders, a simple orders collection and a full orders collection. Once we are in the listing view, we'll use the simple orders collection to get the listing. And once tapped and we navigate to the details for that order, we can get the full order details from the backend as well. Basically what this section says is once the status is updated, we will send out notifications. If it's at the point of being ready to be picked up, we can send it out to the closest drivers. One of the guys suggested that we send out the notifications a few minutes before it's ready for pickup. That's something we'll definitely look into. I haven't added it to this document because that's more of an implementation detail for when we start to build the push notification section that's related to the drivers. And basically going through those steps, there's a lot of things that we'll have to be able to do and organize so that we have a consistent theme throughout the whole product system. The things we learn from this is that the cloud functions will be divided into 2 separate types of functions. We'll have reactive function and we'll have the idle functions. Reactive functions are the ones listening to changes and that reacts to triggers. This will only react to data being updated in a document or added to a new document. This means that when we want to handle new document or new data being added, we make a reactive function and then we react to that information and perform our action. Then we have an idle function. These are functions that will stay idle unless called explicitly from an HTTP request through the Cloud Functions SDKs. You can look at this in terms of the checkout request or the function to add a payment method into our system for the user. I'm going to switch over to the system technical overview because it has all of these things better summarized with the feedback and the discussion that happened here in the document itself. So after that thing, we have all of these data models defined, which we've defined 9 of it. These will be the models required at a high level to carry out the actions that we just spoke about in those steps. This does not detail the models in a completely detailed manner. For instance, the address will be its own model in the code, but we are not talking about the code at this point. Payment method will also have its own model with its own properties, but that won't be covered at this point. So basically we have 9 models. We have the merchant, menu, product, and the product option. Those are the models relating to the merchant, so everything that the merchant will need to operate. Then we have the only model that comes from the user side, which is the user model. This will maintain the name, address, payment method, and account details. And the next set of models is the models required to connect the user to the merchant's products. This will be our cart, which represents a set of products that the user wants to purchase. The order, which is basically a promise made between the merchant and the user that describes what was ordered, what its state is, and who it belongs to. And then we have our delivery model, which is the model that will be used to track the delivery contract. This is where we'll have the location of the user, the restaurant ID, the delivery address, the pickup address, the time picked up and the time delivered, everything that describes a single delivery. And then we have our driver, which will represent a registered driver that can log into the driver application and take a delivery from a merchant to a user's location. That's basically the major models that I could identify and the things that will most commonly be spoken about when talking about the system. Then after that, we have to just define the collections, and then basically the backend entire system will be complete. We'll follow the same setup as this, where we'll cover the merchant side first, then the user, and then the collections required to connect the user and the merchant. The first one is restaurants collection. Each restaurant will have a collection internally called menus, which will contain all of the products for that menu, and then they will also have the options. Now, the way that it's detailed here is not reflective of the thing that was discussed with Jorgen, I'll just say it like that, I don't know if it's correct, sorry if it's not correct, but basically mentioned why would we have the options per product if we can define all the options globally and avoid a situation like this, where we'll have option name as cheese and the items defined like that with a certain price, and then having to define it again for the second burger. If we had all of these options globally, we'd be able to attach the options from that list to the product. The main problem I can see with that is that for some burgers, something with the same name will cost a bit more. I've seen this multiple times. I've seen this in the current system that we did build, and it's the only reason I would want the options to be maintained within each product. We can discuss this more. If you have any opinions on that, please go over to FilledStacks, to github.com/FilledStacks/boxedout, and go to the discussion called product architecture planning, and in the Firestore collections, please leave your reply so that I can know if you have a better way to do this, because I would appreciate if we can make a decision on that as well. Yeah, so that will represent everything required for a merchant to operate on our system. The next thing will be the users collection, which will store the information of the user as a document. It will contain the payment methods, which will be tokens, the card brand, and the last 4 digits so that we can display that information when showing the card. It will also maintain the user's addresses, which is a collection of the stored addresses that the user has added to their profile. Then we can move on to the collection required for these two to communicate with each other. Cards, orders, deliveries, drivers. It is exactly what you think it is. Each of these things will store the models that they represent, and it will be an infinite history collection so that we can always go back and see what happened. That's everything I wanted to cover. If you wanted to read more about why we are using the cloud functions, what they are for, please go over to this technical document. There's a question linked that I think if you are confused about why we are not using the traditional SQL with API endpoints, there's a question linked in here that's a part of the major discussion where I answered a lot of these questions. So if you have questions, please go over there. If you want to continue the discussion, please join the Slack. I have a boxed out channel there where I'm chatting. It's not very active, but I think as soon as we start writing the code and the contributions from the open source start coming in, that will have much more discussions and a bit more activity on that channel. That's it for this video. Next up, we will be setting up this entire backend with the collections and writing some scripts to pre-populate the collections with data so that we can start writing the code to interact with that data. Thank you guys for watching. I wanted to mention that one of the goals for FilledStacks is to help with the state of the Flutter development. That's not saying that the state isn't good, but I've seen a lack of coding principles in most of the code bases that we've looked at, and I think for us to be able to help more in the community, it would be great if the channel can grow a little bit more. We are currently at 38,000 subscribers, and I would like to get this channel to 100,000 this year. So if you can, please share the video. If you like any of the previous videos, I've never asked for a subscription or to share that or anything. Please go back and find your favorite video, share that. I would appreciate that. The FilledStacks team will appreciate that, and it will help us to get closer to our mission of helping 1 million developers become senior engineers in their current positions. I hope this series will help with that. I think it definitely opens some of the doors to more planning, and I'm excited to start with the coding for this product. Let me know if you have any feedback, and I'll chat to you guys next week. Bye bye.